G'day and welcome to the second video on probability tables. This is exercise 8.2. So in this one we're going to be using the probability tables to work out things like expected number, median number and all of those types of things. Okay, so I'm going to use the example that I used back in the previous video, and what I want to find out is the expected number or the average number or the number that you would got if you were to run this trial a number of times. Now the expected number, E of x, is equal to this funny little symbol, which means the sum of x multiplied by the probability of x happening. So for example, for this case here, it's 0 times 0.02 plus 1 times 0.13 plus 2 times 0.38 plus 3 times 0.17 plus 4 times 0.05 plus 5 times 0.25. Okay, so we actually multiply each outcome with the probability of that occurring, and we end up getting an answer which I believe is 2.85. Okay, now obviously you can see that the expected number is actually not a discrete value at all, which it's sort of helpful, but it's not overly helpful because I can't get 2.85 as a number, but that's the expected number that I could get. So which one is most likely to occur, or the average number to occur, probably between 2 and 3, probably closer to 3. But sometimes the expected number is not really the best thing to go by. In fact, sometimes the median number is more helpful. The middle number of the outcomes, but particularly if it's number of traffic lights that you go through or something like that. Who knows? The median number is actually when the sum of the probabilities is equal to a half. So the midpoint, midway rule, like the midpoint of this distribution here. So for example, if I, for this one, if I add up 0.02 plus 0.13 plus 0.38 until I get to a sum of a half, or until I get over a sum of a half, I should say, then we consider that is the median. So 0.02 plus 0.13, that's 0.15, that's not good enough, it's not over 0.5 yet. But then when I add 0.338, that takes me over 0.5. In fact, it takes me to 0.53, and so therefore the median of this distribution is 2. It doesn't matter how far over 0.5 I get, but I just need to get over 0.5. Now again, sometimes the median number is not very helpful. Sometimes the mode is much better for us to look at. What's the most likely outcome going to happen for this? Number of traffic lights that you're going to encounter. The most likely number of traffic lights that you're going to encounter is going to be the one with the highest probability, because that's the one that's going to come out the most, I guess. And so in this case, it's actually 2. So 2 is the most likely outcome that is going to come up if we did this trial. Now, a couple of other things that we need to know about these distributions are the things called the variance and the standard deviation. Now, to work out the variance, we use this formula here, which we've seen before, E of x squared minus the E of x all squared. And so this one is actually, if you remember correctly, that's just the mean. So E of x squared minus the mean squared. So we already have calculated the mean, so that's helpful to us. But to calculate E of x squared, we use this formula here. So it's x squared multiplied by the probability that x will occur, and the sum of all of those, and then minus, that's the mean squared here. So I do 0 squared multiplied by 0.02 plus 1 squared by 0.13, so on and so forth until I get all the way to the end. That's this one, and then I subtract the mean squared, which I know is 2.85, and hopefully I will get an answer. So E of x squared is actually going to be 10.23, and I subtract 2.85 squared, which ends up being 3.1225. And so if I want to know the variance, I do 10.23 subtract that oh, did I say 3.1225? I meant 8.1225. Yeah, that makes more sense, if you square 2 or something close to 3. And I end up getting my variance ends up being 2.1075. Okay, now remember the variance by itself doesn't really mean too much, but what we can do once we know the variance, we can actually find the standard deviation, and that kind of helps us a little bit more. So that's to work out the variance, and then the standard deviation is simply the square root of the variance. So in this case, the square root of 2.1075, and if you bear with me just a second, I'm going to find out what that is, and it's 1.45172. Now we can use the standard deviation to work out how spread out the data is, and we find the middle point, the median, and then we can get the data either side of that. Now the one thing that you should know, sorry, not the median, the mean. One thing you should know is all of the confidence intervals that we worked on before, they all still apply in this case. So, running low. Oh well, we'll get back to that in a second. The probability of one standard deviation either side of the mean, so the mean minus a standard deviation and mean plus the standard deviation, is still approximately equal to 0.68 or 68%. And two standard deviations and two standard deviations, that's approximately 95%, or 0.95 I should say, and three standard deviations and three standard deviations is approximately 0.997. So those all of those things still apply. Okay, so in this video we've looked at all of the, these measures of spread and things that we've done for probability tables: expected number, mean number, mode, variance, and a standard deviation. So hopefully that's helped, and now you can do 8.2. Thanks very much.